Hello everyone, in this video we are going to see about the concept of unsupervised learning. Let us see the definition. Unsupervised learning is the process of training a model using unlabeled data. That means the system is provided with input data but no corresponding output. So we give the data as input X but we don't represent the output Y. Okay, that is unsupervised. Okay, so normally we have data to train any model, and this type of data as input, but there is no corresponding output. Unlike supervised learning, there is no right or wrong answer. Instead, algorithms are tasked with identifying patterns or nodes within the data, which means we cannot say some answer is right or wrong. That means the algorithms are expected to learn the patterns from the data or the nodes within the data. That is the unsupervised learning. In supervised learning, we expect the output, then we say this is the answer and that is the answer. It may be right or wrong, but unsupervised learning, there is no such concept. Let us see the process. So here we have the collection of data along with the noise, and we are going to find the signal in the noise. Okay, so the signal is mixed with the noise, and we have so many processes, a statistic framework which says how to the concept of unsupervised learning, clustering, and association algorithms. Okay, so here we have some layers of learning, and then we bring some data like this, and then there are some groups of data we have found out from the signal, and then we try to make this group among the mixed data from different layers, so that forms some cluster. Okay, so here we have some clusters A, cluster B, and here one more cluster B, and so on. So that means cluster are a group of data which has some related information. Okay, so here we also have a concept of association where one data is associated with the other data. Okay, the rules here that it says the association rule. So this is the framework of how the strategy of unsupervised learning works. Let us see in detail next slides. So here that unsupervised learning, we know it is learning without the answer key. Okay, so this is a supervised learning where we have desired input neurons are there, and there are some hidden layers which process the input, and the expected output neurons also specified. Okay, so the formula is the n is equal to ns, that is the sample into alpha, which is the scaling factor, into ni plus no, means input and the output neurons. Okay, so this is the supervised learning, and hidden layer is NH is hidden layer. This hidden layer is found out by number of samples along with the input added with the output neurons, and it is multiplied by a scaling factor. Okay, so this is the formula to find out the hidden layers in supervised learning. Then what is unsupervised learning is? It's the process of learning a model from unlabeled data. So input X is supplied without output, leaving algorithms to determine nodes within the data without a right or a wrong answer. This one just we have seen in the previous slide. So here you can see so many data are there, and we have different, this is one cluster, a group. This is another group, a cluster. This is another group, like this. So many clusters are formed based on some criteria. They have some similar attribute or similar property to become a cluster. Okay, so in the unsupervised learning, we remove the y, the output, and no constraint is also given. It organically the structure is emerged. Now this is organically means that it has some common relation and they are forming a group, that is the cluster. Okay, now let us see the architect building structure in chaos. So here how the cluster is formed, we are giving the examples over here. So clustering is the process of discovering relationship within the data to determining groups that have formed organically rather than define them beforehand. So the group is formed as and when data comes. For example, the patient monitoring system, where grouping the patients of similar profiles together. Like example, a patient with the BP or a patient with the sugar, like that some profile, common profile, that is one cluster. And here anomaly reduction means some similarities we are able to detect, which means yeah, spotting the outliers in claims or transactions. We have some claims or transactions. Outliers means which is outside the group, which is different from the group, that is the outliers. Okay, so when we are able to find out the anomaly, here we can see these uh, blue lines come in anomaly, where this brown is a outlier. That means it goes beyond the range, that is the outlier. Okay, and another is the treatment pathways, defining groups based upon the medication or condition. So based upon the people condition, we define into different groups. This may have treatment 1, they may have treatment 2, and other may have treatment 3, and so on. Like that, we are making some groups of patients in the medication or a condition. And another is the activity tracking, detecting activity through motion sensors. So motion sensors, the movement, based on the movement, the activity is tracked. Okay, so the activity is also made into group. It's a form of clustering. Okay, and now let us see the one algorithm in k-means. That is, the clustering is k-means clustering. What does it say is we are finding the center of gravity. What does it mean is we find a point here like this, and whichever point can be assembled with this point, we make a connection. That means we are making a centroid. A gravitational pull is given to make it as a group. Okay, so what the principle says, the algorithm aims to find k similar groups. Different data are there. We are going to find k similar groups. It is iterative and centers around the centroid, a collection of attribute values that define a resulting cluster. That means we form a cluster based on some attribute values. Okay, and similar attributes form a collection, and they have some center point, and these data collects under around the centroid. Okay, so one centroid will form one group. Likewise, we can have many centroids, different groups. Okay, so we can have k similar groups. That is the k-means algorithm. So what it does is data points are assigned to a cluster based on the distance between the point and its centroid. What does it mean is centroid is the focus point, and the points whichever around the centroid is connected to the centroid. Whichever is close by, that means whichever the forms has the capacity to form a group, that forms a cluster. Okay, so the equation given is argmin summation of distance of ci comma x the whole square, which means this ci is the collection of centroids, and standard Euclidean distance, this is the formula, and the data point which we give the input. Okay, this formula helps to find out the equation, okay, for the centroid gravitational pull. Okay, so now how the process is continued, the k-means algorithm is continued means initializing, yeah, for example, k is equal to 2. We are just assuming two different centroids and then assign the points randomly around the centroid. Okay, then associate. What you do is we connect the centroid with the points around the points over here. So this is one cluster we have found. Again, another center point, we have found some connections, connect some points to form a cluster. Then what we do is recalculate this process again and again, means we try to add more and more data into the new centroid. Okay, we make some members for the centroid. Likewise, when you repeat the process at some point of time, there will be a fixed cluster. That means the process will not change anymore. The shape is not changed anymore. The data is fixed. The data becomes fixed. That is called as that is the end point. Okay. So process continues until clusters remain unchanged. So at one point of time, the cluster stop changing the shape. In that case, we have to stop the process. Okay. So initialize, associate, recalculate, and loop and exit. This is the way to find the k means. That means k different groups of data clusters. And the next is how to find out the association. So we know that We have two major things, clustering and association for the unsupervised learning. And here this is the associative learning, rule learning. What does it do is it extracts the rules that explain perceived relationships between the variables in large multi-dimensional data sets. So we have multi-dimensional means many attributes are there in the data set, and what we do is based upon the context we connect the data with the context. Okay, for example, this is a market basket. When we buy pizza, we also buy wine in order to make the combination. If pizza then wine, to make it, that's the true. Then lettuce, and if we buy lettuce, we always also buy tomato, cucumber, onion to make the salad, which means this become one context. Okay, likewise another context is for the patient pathway is a clinical data. So we have some symptoms for a group of patients. We diagnose the disease. Okay, that is one context. Then we have some another context called patient comorbidity, means that the extra, that is the by the root cause of the disease, it may also associate some other disease. Okay, that is the uh, point here. So analyze the pathways, then we find the patient who are having the comorbidity pathways. Okay, likewise another case, the medical data, the medication combination. This combination will not work for some patient, and for some patient it will have some adverse effects. So by this they identify the adverse effects from the medication combination. So likewise the association rules are extracted based upon the relationship between the variables in the data. Okay, so now how to measure the strength of the association? We have three metrics: support, confidence, and lift. Okay, so what the support says is absolute frequency. How popular is the item set? Okay, that means particular item, how popular means how frequently it occurs. That is the absolute frequency. Okay, so the formula is we have set x and set y. What does it say is set x and set y. The formula is support is equal to probability of x union y is equal to count of x union y divided by total transaction count. So the percentage of transaction that contain both x and y, that is the support vector, that is support metric. Second metric is confidence. What does it say is the correlative frequency. If this happens, that also will happen. The concept is if x happens, how likely y also will happen. Okay, so this is the diagram showing that the probability of x to happen when y, if x happens, how y also will happen. Likely means the probability that y also can happen. Okay, so that is the formula given over here. Confidence is equal to probability of y over x is equal to count of x union y divided by count of x. The next attribute is the lift, accounting for probability. What does it say is confidence can be misleading if an item is naturally very popular. Lift determines how likely item y is given that x occurs while accommodating for y's general popularity. That means this limits the popularity of y. It is an additional metric over the previous one, confidence. Here they fix some general availability of one data y, and if that y is given, what is the probability of x occurs? That is the lift. Okay, so the formula is lift is equal to support of x union y divided by support of x into support of y. The association rules ultimately determine the probability of y given that x occurs. Okay, so these three metrics measures the association strength, and the other is the a priori mining frequent relationships. So here this particular attribute says the most popular algorithm for pattern mining. It identifies features and items that occur together using a bottom-up approach. So here the idea is For an item set to be frequent, all of its subsets must also be frequent. Here the implication is if pizza wine is rare, then pizza wine cheese must also be rare. Okay, so this is the subset rule. If this happens, that also must happen. That's a subset rule, and that defines the frequent relationship between the attributes of data. So the thing given is here level 1 is there, and then in level 2 we combine different combination of with A and B, A and C, and A, B and C, some combination, and we discard some combination. That means if A occurs, D may not occur. So we are pruning the particular branch. Likewise, B command is also pruned. That means which is not possible. Okay. And then from this association A and B, we design the association A, B, C. Okay, that means level 3 the triplets. So with the A, B, we also include the C from this combination. Okay, this color says the C is taken from this combination. Okay, so this is the bottom up approach. So this give the that's the possibility of the relations to present. Okay, so this is how the association this is how the a priori goes, how it minds the relations, frequent relations between the data. So this is a workflow for a priori workflow. Item sets are given over here. From that you generate k item set. Okay, that is means one particular k item set candidates. Then with that we make some checkpoint, check support. Support is the we learned what is support. Okay, so support, from that support we prune means that means we are discarding unwanted data, then we are checking for the support value, then we get the frequent items, then we check set of k minus 1 frequent item sets is null. Null means that's all, we have found out everything, we can go and stop the process. Otherwise generate more and more item sets. Okay, so the explanation of this algorithm is apply minimum support, find sets where support greater than or equal to minimum of support. Then second process is generate the candidates, expand selection to k plus 1 item. We have found k items, then repeat this for k plus 1 items also. Then prune, if a subset is infrequent, you have to prune. The larger set cannot be frequent, so you have to prune. It means you have to cut down the branches. Okay, this is how the a priori workflow happens. So that's all for the concept of unsupervised learning. Hope it is easy and simple to follow, and thanks for watching.